it is given to me that y lies on CD and OX, Y, they are collinear. So y should be somewhere here. In order for me to solve for the position vector of y, we will do the same thing as what we have done in part 1. We will form the equation of the line that passes through CD, and we will form the equation of the line that passes through OY or OX, since OX, Y, they are collinear, so it is that same line. We will try to find the intersection between the two lines, and that should give us the position vector of Y. So let's first work on the equation of the line that passes through CD. So I'm going to go for the vector CD first, which is going to be OD minus OC. So it will be B plus 5A minus away 2A plus 4B. So 5A minus 2A, this gives me 3A, and B minus 4B, this gives me minus 3B, which means that CD is going to be 3 of A minus B, which means that CD is also going to be just parallel to A minus B. I'm going to make use of this A minus B to form for myself the equation of the line that passes through C and D. That will be R is equal to, I can either make use of the position vector of D or C. Let's just go for C. So that will be 2A plus 4B. Then plus, I'm going to use an arbitrary constant. Let me go for gamma. Gamma of a direction that is parallel to CD. I'm going to go for the simpler version, which is A minus 3B instead of 3 times of A minus 3B. So it will be A minus B here. So I have one equation, and I'm going to form the equation of another line that passes through OX or OY. It is the same line. Let me just call it line OX. So this will be R is equal to, it passes through the origin, the simplest possible point, then plus and sigma of a direction. Let me go for OX as the direction. From the previous part, OX is B plus 5 over 4A. So the line is going to be just sigma of B plus 5 over 4A, which means that at the point Y, the R and the R, they are going to match. So I'm going to let this be equal to this, which will be 2A plus 4B plus lambda of A minus B. This is going to be equal to sigma of B plus 5 over 4 of A. Let us do the same thing as what we have done in part 1. Let's try to rearrange and group all the A's and the B's together. So on the left hand side, we have a 2 plus gamma of A. Then plus we have a 4 minus gamma of B. This is equal to, this times this, 5 over 4 sigma of A, and this plus sigma of B. So if I were to match the left and right hand side, A to A, B to B, we will have this matched to this. So 2 plus gamma, this is equal to 5 over 4 of sigma. So my first equation in terms of gamma and sigma will be 4 gamma minus 5 sigma is equal to minus 8. So this will form for me my first equation. Then matching B to B, it is 4 minus gamma is equal to sigma. This gives me my second equation, gamma plus sigma is equal to 4. So with these two equations, this and this, we will just press this into the graphing calculator to solve it as a pair of linear simultaneous equation. That will give me gamma from GC. Gamma will be 4 over 3, and sigma is going to be equal to 8 over 3. This will give me OY, the position vector of Y, by substituting this into here. So OY is going to be sigma, which now we know it is 8 over 3. So 8 over 3 of B plus 5 over 4A. So this is the position vector of Y, and we are supposed to find the ratio of OX is to OY. And what we realize is that this is actually just OX. Right, from the first part, we know this is OX. So, which means that OY is just going to be 8 over 3 of OX. This will also tell me that distance-wise, OY The distance OY is just 8 over 3 of the distance OX, which means that OX over OY is going to be equal to 3 over 8. This tells me the ratio of OX is to OY, and that is 3 is to 8.